Okay, for question 18, right? The question asks for instantaneous power input by Sam on the crate 2 seconds after he started to accelerate. So on the surface, right, this looks easy. Simply, right, P equals to FV. And V, right, is not difficult to find because, right, we know initial speed is 0.8, acceleration is 1, and the time is 2 seconds. So you can actually find the speed as 2.80 meter per second quite easily. But what is this force? Okay, so let's consider, right, the object. Okay, you have mg acting on it, you have some friction, you have Sam's pulling force, and let's just call it F, and you have normal contact force. Okay, you notice, right, that the normal contact force is smaller than mg because, right, in the y direction, the vertical component of Sam's pulling force, right, will combine with normal contact force to support the whole weight. Okay, yeah, so that is why, right, the normal contact force is not equal mg but smaller. Now, right, what do we use to calculate, to use as the F in this case, okay, to calculate the power? We don't actually use the entire pulling force, okay, but we actually use, right, the component of the pulling force, right, that is parallel to the V. Because, right, if we go back one step, okay, if we go back one step, before we get power, right, we're actually talking about work. So work done by Sam will be equals to Sam's pulling force times the distance in direction of force. Okay, or force in direction of the motion, right? Okay, times the distance. Okay, so in this case, right, we actually need to just consider the horizontal component of Sam's pulling force rather than the whole thing if we want to substitute into this equation. So P equals to F in the x direction times V. F in the x direction, right, once again you need to break down again. So F in the x direction minus friction equals to MA. So F in the x direction is equals to friction, which is 200 plus M, which is 10 kg, times A, which is 1 meter per second square. Okay, so that gives us 210. So we have 210 times 28, and that gives us option C, 588 watt.